Hello. This is going to be a quick little tutorial on how to read and write Touchstone files, or S2P files, as they're more commonly known. An excellent resource for doing that is this application note by Maycom. I believe that's how you pronounce it. Application note 3009. So it basically gives the file format that you want to use. Um, but honestly, it's better to explain it in my own words than to read this sort of deal. And this doesn't really give a good sense of what the file should look like. So that is why we are going to do this problem from Pozar, example 12.5, using QucsStudio, or as it's now called, uSimmics, or MicroSimmics. I guess that's what they want to call it. So this one calls for a noise-based simulation. So at 4 gigahertz, the S11 is 0.6 at negative 60 degrees, S12 is 0.05 at 26, 2.1 is 1.9 at 81, 2.2 is 0.5 at negative 60. The F minimum is 1.6 decibels. The S opt is 0.62, and it's going to be at 100 degrees, and then the noise resistance is 20. So yeah, let's get this started. So the way, here we go. So the way it's telling you to add this is that, honestly, I always do this line so whoever's reading the S2P file knows what it's going to be. So the first thing after the pound sign is you have your scale of what you want the frequency to be. So I think it only really supports hertz, kilohertz, megahertz, and gigahertz. Would you look at that? I'm correct. So put that then. And then the next one is the type of parameters you want to do. Typically, you only really want S, but in case you want to, you have the possibilities for Y, Z, H, and G parameters. And then the next one, MA, is what you want the representation to be. So because the book gave it in magnitude and angle, we're going to use MA, which is magnitude and angle. Because the other ones are going to be, MA is magnitude and angle, dB is decibel magnitude, and then normal angle. RI is real and imaginary, so that would be the R plus JX sort of deal with that. Most of the time, a data sheet's probably either going to give it an MA or dB. And then the next one is R50. I think the R is required. You can't really change it, but 50 is what you want it to be in reference to. And since our characteristic impedance is 50 ohms, we're going to do 50 ohms. So for the scattering parameters, we start out with the frequency we want to do. Since we're only doing one frequency, we start out with 4.0. And then the way this is, exclamation marks are comments. So it's going to be freak, S11 mag, S11 angle. And that is the way it is done. So we have 4.0, whoops, wrong tab, 4.0, so we got 0.6, negative 60, oh, this thing sucks so bad. Okay. Because this is not a native Linux application, it's only Windows, so I'm running it in Wine. That's why it looks terrible. But if you ran this on Windows, it would look much better. So we got our... So that's it for our actual, the S parameters. But we also want to include noise. So the way this works is that the parser The second it sees like a repeated frequency of the same, so like say we had like all the way up to like 9.0 or something. If it sees another 9.0 in the frequency section or below 9.0, so if like the next one is 8.0, it will automatically figure out that, hey, this is noise. And so I just like to do a noise comment here. And then per the application note, the noise parameters is going to be freak, noise, figure, the magnitude of gamma, the degrees of gamma, and then Rn. But there's a caveat with Rn. We'll get there in a second. So the book tells us it's going to be the F min is 1.6 dB. So first we do 4.0, 1.6, easy peasy. We do 0.62, 100, and then the Rn, which is actually a little confusing because it's 20 ohms, but everything in here is going to be normalized to 50 ohms. So you got to do 20 divided by 50, which I think that's 0.4. So save that, and we're basically done. So it's going to interpret this stuff up here as scattering parameters and the stuff down here the noise. And we can see that. Just make sure this doesn't open there. Save it, run this, delete these two. Diagrams, tabular. So we want the S11, S12, S2, delete him, and do, oh Lord, come on. S22, click OK. We reference this with the book. 0.6, negative 60, 1.9, 81, 0.05, 26, 0.5, negative 60. So yeah, it read it correctly. Now we're gonna want to do the same dealio. Oh wait, I forgot to. First of all, in order for the simulation to actually have noise, you gotta check the noise first. I'm so silly. So now delete all this. Here we go. We got the noise figure minimum, the S opt, which is the same thing as gamma, and then the noise. So here we got, I think noise. I can't remember what noise figure actually. I think that's like the max or something. I'm not sure, but we have the F min is 1.6 dB. That's what that is, 0.6 at 100 degrees, and then Rn is 20. So hooray. And just to show you that the rest of the problem is doable, I want the rollet, or rollet, that's how you pronounce it, and then the determinant, I think that is. Just copy this. In this, it's really easy. It's just that. And then this next one, I think it's the this? Oh, wait, crap. Gotta do absolute.s. Yep, 2.778, 2.78, basically the same thing, 0.37, 0.37. Yeah, we're getting the right stuff. Let's not worry about that crap. And here, okay, so want to do the noise figure circle at 2 dB and 1.6. So get our Smith chart out here. I'm trying to remember. Is it noise circle? Uh, let's try that. Uh-oh. Let's do the help index real quick. This tells you all the math functions. It's really nice. Here we go. Okay, no capital N to the constant noise figure dB in dB. Okay. So no capital N. Let's do NF min. So might not be that visible, but it's that tiny, teeny dot right there, which tracks with what our thing is, because this whole circle is 2 dB, and this tiny little guy is 1.6 dB, because that's how it works with gain circles too. The max that it can be is this minuscule freaking little dot there, or it's the smallest circle. So there, and if we do the exact same thing, new graph, put 2 in there. We got a much bigger circle, and this kind of, I think that's, what are you? Put you in rectangular real quick. 20, no, I want it normalized. Come on. Yeah, the 0.5 line, I believe. Is the, well, kind of on this guy, I assume this is the 0.5. It overlaps the 0.5, but here, it's more like the, oh wait, I'm overthinking it, yes. So this is actually, I'm dumb. This is the 0.4 marcation. So yeah, it's all good. It's all well and good here. So yeah, that's how you write and interpret as parameter files with noise. I know this is a not really good tutorial, but it's what it is. I've never seen a YouTube video actually discuss this, so I figured, why the hell not? Well, I hope you found this informative, and have a good one.